All right, this video is a second video of two. This one just has some examples in it, so hopefully if you're wondering how to solve absolute value equations, make sure you watch the first video. I'm going to move fairly quickly in this video just because we've already understood the method. We just want to practice a couple of times. So I've got a couple of absolute value equations here on the screen, and remember, in order to solve, the first thing we want to do is get rid of anything on the outside of the absolute value. We want to isolate our absolute value. So let's go ahead and subtract 3 in this first equation. So I've got the absolute value of 5x plus 1 will be equal to, again, plus 3 minus 3 is gone, but 14 minus 3 is 11. Then we're going to split it into two parts. Okay? We've got 5x plus 1, which could have come out to a positive 11, or it could have been a negative number, which if you put an extra negative on there, would then make for a positive, again, 11. One option, again, for that equation on the right, is if you immediately divide that negative over, maybe you prefer to say that 5x plus 1 equaled 11, or that 5x plus 1, again, making sure those negatives cancel each other away, is equal to negative 11, right? Because that absolute value could have been a positive or a negative number, right? A positive or a negative 11. Then we'll just continue to keep on going here, right? We've got 5x plus 1 equals positive 11 or negative 11. Let's subtract 1 on all sides. So 5x could equal 10, or 5x could have equaled negative 12. And then finally, let's divide everything by 5, right? Same thing on the other equation. We need to get rid of that 5. And x could be 2, or negative what would essentially be 2.4. If you want to leave that as negative 12 fifths, that's a perfectly good answer as well. And in fact, it's actually easier to check. If you take your numbers and you plug them back into your equation, we want to check and make sure that we would actually get that 14, right? So let's take 2 and plug it in. 5 times 2 would have been 10, right here. Plus 1 would make 11. The absolute value of 11 is 11. And 11 plus 3 is 14. I would say that that answer checks. Then we could do the same thing with the negative 2.4. Negative 2.4 times 5 is actually negative 12. Plus 1 would have been negative 11. And the absolute value of negative 11, again, is 11. Plus 3 gives you 14. I would say that both of those numbers are going to work, very simply. Don't be afraid, or forget to check your answer. Not only be afraid of it, but go ahead and do it. It's always a good idea. And here's why. Let's take a look at this problem over here at the right. First thing I'm going to do is divide away the 3, because again, I want to get that absolute value of x plus 4 totally by itself. Then let's go ahead and split up the parts. And note to self, I'm going to come back to this step. Don't be afraid to pause the video and take a really good look at that equation right now. You might see a slight problem there. But I'm going to go ahead and continue. X plus 4 could equal negative 4. Or x plus 4 already being negative could have come out to negative 4. All right, I'm going to plug that positive and negative. I'm going to plug that negative in front of my quantity, just like I did over at the left. Then I'm going to go ahead and divide it away as I did previously as well. X plus 4, right, with that negative canceling off the bottom there, would be equal to a positive 4. Subtracting 4 from both sides, x could be equal to negative 8, or, again, subtracting 4 from both sides, it could be equal to 0. If we take those numbers and plug them back in, you're going to notice something kind of funny happening. Again, I'm going to plug it back into the original equation. 3 times the absolute value of negative 8 plus 4. Well, that's 3 times. Negative 8 plus 4 would have been negative 4. But its absolute value is positive 4. And we get 12. But the problem is we wanted negative 12. So negative 8 does not work. If you go back and check all your steps, it's not that we did anything wrong, but note to self that negative 8 doesn't work. And even worse, if we take that 0 and plug it in, right, then it would have been positive 4, still positive 4, we still get 12, which again is not negative 12. Both of these numbers, right, when we went to check them, did not work. And the reason that is they are what we call extraneous solutions. -8 and 0, which I'm just going to label ext for extraneous, neither of them works. And again, it's not that we did anything wrong. You could double check all of your steps. We didn't take any incorrect algebraic steps. The problem is we skipped over something that we shouldn't have. And that's back here where I put that asterisk. Take a good look at that equation. The absolute value of a quantity is equal to a -4. Well, if absolute values are defined as distances, absolute values are making things positive, then they should never be equal to negative numbers. And by kind of ignoring that fact and just continuing to solve, we found a couple of numbers, right? Doing our algebra exactly how we were supposed to. But we found numbers even though we shouldn't have, right? We shouldn't have been able to do that. So if both answers are extraneous, or if we notice that the absolute value is equal to a negative number, right? There's nothing else outside. We got rid of that 3. But the absolute value, its whole self here, is equal to a negative number, then what we know is that there really is no solution, right? There is no number that when you plug it in and take its absolute value, it will ever give you a -4. Or taking that value times 3 would have given us a -12. No solution there. Watch for those extraneous solutions. Again, that's why we say make sure you check your answers. Now, in addition to checking our answers and finding extraneous solutions, we should be able to use these absolute values to do something. And there is a quick and easy application called the absolute deviation. Deviation is another word for difference or subtraction. What we're saying is the absolute deviation of two numbers, right, is the absolute value, right, the distance that those two numbers are apart, their difference. But the problem is sometimes differences can come out negative. But again, a distance shouldn't. The deviation shouldn't. So again, we throw that absolute value on there. So let's see a couple of problems working here. Given a value of 8, we want to know what number or numbers, right, are 3 units, right, the absolute deviation of 3 from 8. So what I do is I plug my numbers in, x minus 8. What number is minus 8, right? It's how far from 8. Its distance being 3 units. What two numbers would be 3 units from 8? Well, very simply, we're going to split it into plus and minus, divide that negative over, and again, add 8 to all parts. And doesn't it make sense that 11 is 3 units above 8, 5 is 3 units below 8? But again, a great way to use this absolute deviation, absolute value idea. Let's do the same thing on the right. Again, given a value of 50. 50 is going to be what we're aiming for, right? 50 is kind of our goal. What I want to know is what numbers are 15 units, right? Absolute deviation is equal to 15. So 15 equals x minus 50. What two numbers, when you subtract 50, right, would have been 15 units away? Again, split it up, positive and negative. You can divide that negative directly over the other side, and then add 50 to all parts. And it makes sense. 15 above 50 is 65. 15 below 50 is 35. Now, that might seem really simple. You might think, well, why can't I just take 50 and add and subtract 15? Well, you could. But again, this idea of solving the equations, this is algebra, that's going to help us big time when we start talking about inequalities, which my guess is what you'll probably study tomorrow. If you have any questions about solving absolute deviations or just solving absolute value equations, make sure you talk to your teacher and have a great day.